Welcome to today's lesson, Inverse Trigonometric Functions. Now, through your guided investigations, you should have learned that as long as we restrict the domain of each of our 6 trigonometric functions, that its inverse can also be a function. What's important about this is that in order to be a function, one input goes in and only one angle can come out. And so we need to memorize these restricted ranges for our inverse trigonometric functions. So we'll start with inverse sine, inverse tangent, and inverse cosecant because they all share a similar set of ranges. These 3 functions you would answer from negative pi over 2 to pi over 2. So for example, the inverse sine of 0 would be 0 because the angle that has a sine that's equal to 0 is 0. While yes, pi also has a sine that's equal to 0, pi is not in this range of answers. The other 3 trigonometric functions, inverse cosine, inverse secant, and inverse cotangent, also share a range of answers, and they go from 0 to pi. So notice that you will never give an answer from quadrant 3. All positive inputs to inverse trigonometric functions give an answer in quadrant 1. The negative inputs will give answers in quadrant 4 for inverse sine, inverse tangent, and inverse cosecant. And negative inputs for inverse cosine, inverse secant, and inverse cotangent will give angles in quadrant 2. Example 1, find the exact value of the inverse sine of 1. Well, if we're looking at our unit circle, we look for a y-coordinate that's equal to 1 in our restricted range, and that angle is pi over 2. Part B, find the exact value of the inverse sine of negative 1/2. Well, we're trying to find the inverse sine of a negative value. So if we're looking at our unit circle, we're going to see that an angle down here has a sine that's equal to negative 1/2, and this angle is negative pi over 6. Example 2, find an approximate value of the following and round to 2 decimal places. So because it says to round, they are expecting us to use our calculators, and all we have to do inverse sine is to hit the second sine button, 1 divided by 3, and our answer is approximately 0.34 radians. I probably should have mentioned that you need to put your calculator into radians before we start. Part B, the inverse sine of 1/4. And this is approximately equal to 0.25 radians. Example 3, find the exact value of the inverse cosine of negative root 2 over 2. Well, this is a negative input, so our answer has to be in quadrant 2. So I'm thinking about the angle in quadrant 2 that has a cosine that's equal to negative root 2 over 2. And that angle is 3 pi over 4. Part B, find the exact value of the inverse tangent of negative root 3. So inverse tangent of a negative has to be in quadrant 4. The angle that has a tangent, or the reference angle that has a tangent that's equal to the square root of 3, is pi over 3. So to get a tangent equal to negative root 3, our answer has got to be negative pi over 3. When you compose a function with its inverse, they cancel each other out. Now this works most of the time with trigonometric functions, but we are limited to considering the domain of the functions, as you can see in this table. So let's see what we mean by that. Example 4, find the exact value of the following. The inverse sine of the sine of pi over 8. Now it doesn't even matter whether or not I know what the sine of pi over 8 is. I know that pi over 8 is in quadrant 1, and because quadrant 1 is part of the range of inverse sine, these will cancel each other out, and my answer is going to be pi over 8. But now watch what happens if we do the inverse sine of the sine of 5 pi over 8. 5 pi over 8 is more than 4 pi over 8, or pi over 2, so 5 pi over 8 has to be in quadrant 2. Quadrant 2 is not in the range of inverse sine. So let's think about this for a minute. When we think about sine, sine is the y value. So that is how high up this coordinate is. Well, there's also an angle in quadrant 1 that shares the same sign. And we'll find that by finding the reference angle. So if this is 5 pi over 8, the reference angle is 8 pi over 8 minus 5 pi over 8, or 3 pi over 8. So the inverse sine of the sine of 5 pi over 8 has to be 3 pi over 8, so it will fall in the range. Example 5. Find the exact value, if any, of each composite function. So now we want to find the sine of the inverse sine of 0.8. So basically right here, we are trying to find the angle whose sine is 0.8. And then we want to find the sine of that angle. Well, because sine has a range between -1 and 1 and 0.8 is in that range, the answer is 0.8. But for part B, the sine of the inverse sine of 1.8, they're asking us to find an angle that has a sine that's equal to 1.8. Well, it's impossible for an angle to have a sine that is not between -1 and 1. So this one does not exist. Example 6. Find the inverse of f of x equals 2 sine x minus 1. So we want to go back to our 4-step procedure for finding the inverse of a function. First, we replace f of x with y. So we have y equals 2 sine of x minus 1. We swap x and y, so x equals 2 sine of y minus 1. Then we solve for y, so I'll add 1 to both sides, and then I'll divide both sides by 2. And I'm going to have that the sine of y is equal to x plus 1 over 2. Now the last way for us to solve for y when it's inside a function is to rewrite it as its inverse. So if the sine of y equals x plus 1 over 2, then y equals the inverse sine of x plus 1 over 2. And the last step is to replace y with f inverse x. Example 7, find the exact value of the sine of the inverse tangent of 1/2. Well, we don't have any angles on our unit circle that have a tangent of 1/2, but we're still supposed to do this without a calculator. So we do this by drawing a triangle. The inverse tangent of a positive number means the angle has to be in quadrant 1. I'm going to draw a triangle, and I'm going to draw an angle in standard position, and the tangent of that angle has to be 1/2, which means the opposite has to be 1 and the adjacent has to be 2. Now if I want to find the sine of this angle, I'm going to need to know the hypotenuse. So Pythagorean theorem says that 4 plus 1 equals 5, so the hypotenuse is the square root of 5. So our answer, the sine of this angle, is 1 over the square root of 5, or root 5 over 5. Part B, the cosine of the inverse sine of -1/3. So inverse sine of a negative value has to be in quadrant 4. So I'm going to draw a triangle. Here's my theta. The sine of theta needs to be -1/3, which means the opposite side is going to be -1. The hypotenuse is going to be 3. And by Pythagorean theorem, 3 squared minus 1 squared is 8. So the adjacent side becomes the square root of 8, or 2 root 2. And then the cosine of this angle is adjacent over hypotenuse, so this is going to be equal to 2 root 2 over 3. Part C, the tangent of the inverse cosine of -1/3. So now, inverse cosine of a negative means my angle needs to be in quadrant 2. So I'll draw a triangle. Here's my theta. The cosine has to be -1/3, which means the x-coordinate is negative, the hypotenuse is 3, 9 minus 1 makes the opposite side the square root of 8, or 2 root 2. And then the tangent of this angle is going to be equal to 2 root 2 over -1, or -2 root 2. Part D, the inverse sine of the cosine of 5 pi over 6. Well, this one we can get from our unit circle. This would be the same as the inverse sine of, well, the cosine of 5 pi over 6 is equal to negative square root of 3 over 2, because remember, cosine is negative in quadrant 2. Now I need to find the angle that has this sine. Well, if I'm going to be answering an inverse sine of a negative, I'm going to be looking for an angle that's in quadrant 4. So remember, square root of 3 over 2 is the long side, which means my angle has to be my large angle, so this is going to be equal to negative pi over 3. Part E, the inverse cosecant of 2. I'd rather write this as the reciprocal of cosecant, which is sine. So this is going to be the inverse sine of the reciprocal of 2, which is equal to 1/2. The angle whose sine is equal to 1/2 is pi over 6. Example 8, use a calculator to approximate each expression in radians rounded to 2 decimal places. So there is no secant or inverse secant button on our calculator. So what we have to do is we have to remember that secant is reciprocal with cosine. So this is going to be the same as the inverse cosine of the reciprocal of 3, which is 1/3. And if we put that in our calculator, this is approximately equal to 1.23 radians. And part B, the inverse cosecant of -4. Well, cosecant is reciprocal with sine, so I'm going to do the inverse sine of the reciprocal of -4, which is -1/4, and this is approximately equal to -0.25. And finally, example 9, find a simplified expression for the cosine of the inverse sine of x over 3. Okay, there's no reason to do this any differently than what we were doing before. I'm going to draw an angle in quadrant 1 that has a sine that's equal to x over 3. So here's my angle. The sine of this angle is x over 3. That means the opposite side is x and the hypotenuse is 3. Now if I want to find my missing side, I'll just call that a. I know that a squared plus x squared is equal to 3 squared, or a squared is equal to 9 minus x squared, which means a is equal to the square root of 9 minus x squared. So I'm going to call this side the square root of 9 minus x squared. So now that I've drawn a triangle that represents this, I want to find the cosine of that angle. So the cosine of that angle is going to be the adjacent side, which is the square root of 9 minus x squared divided by the hypotenuse, which is equal to 3. That's all for now. Thanks for watching.